All right. Good morning, everyone. So today, this is going to be a pretty short video. We don't have too much to talk about. There's just a couple of little things that you might see on a free response question or you might see in a multiple choice question that I want to make sure we cover so that we have a solid understanding of it. And then we're going to talk a little bit more about influential points, which I know I mentioned a little bit yesterday. I didn't call it by that name. But I did say that we were going to talk about that point that was really far away. So we'll get into a little bit of that as well. Now, you can see the title here, Interpreting a Regression Equation. And so what you might see on a free response question, or you might see as a multiple choice question, is that they might ask you to interpret different parts of that equation. So just to remember, just to get ourselves familiar with what the formula sheet looks like, right? This is what the formula sheet looks like for regression, right? B sub 0 plus B sub 1 x, where obviously here, B sub 0 is your y-intercept. Now, to be fair, AP terminology, they usually just call this the intercept. That's it. You won't actually see it called the y-intercept. They will just call it the intercept. So understand if you see that in a question, they're really just talking about the y-intercept. And then very clearly, obviously here, B1, let me fix that arrow. B1 is your slope. And so you may be asked to interpret either one of these in the context of the question. So in order to do so, it's actually, again, a very formulaic answer, similar to most other things when we're asked to interpret, right? So let's say, right, the question asks you to interpret the slope. Now, if they're going to ask you to interpret slope, in general, here's what we're trying to say here. We're going to say it's the change in y per 1 unit. I don't know why my stylus doesn't want to write. There we go. Come on. X, right? So it's the change in y per 1 unit change in x. So, for example, let's say I've got an equation that looks like y 7 plus 3x, and I'm really only writing it like that because that's what the AP exam will write it as. And let's say, here x is years and y is salary, right? If they ask me to interpret the slope here, right, we would say, and here is the key, because when you use, or when they ask you to interpret this slope, we want to make sure we use that non-deterministic language that we talked about, because it's not a guaranteed increase, right? It's a predicted increase, or an on average increase, or an approximate increase, or we would expect there to be an increase of. So all of these things that say, hey, this isn't guaranteed, but the data kind of moves in this direction as a general trend, right? So here, this interpretation would be, right, for each additional year, all right, let's just pretend, that this is like years worked at a company. For each additional year worked, there is a predicted increase of, let's say this is salary in thousands of dollars, right? Of $3,000 in salary, right? And again, this word predicted is probably the most important part of your answer. If you say something like there is an increase, there will be, like it's guaranteed, you're going to lose credit. Most of the time, and we'll look at some free response questions in class, when you look at the scoring guidelines, it specifically states that you use non-deterministic language to describe the slope or to describe the y-intercept. Right. So, and again, predicted, we have, a couple of words here. We can say approximate an expected, right, in general, an increase of, right? So there's a bunch of different words that you can use there to fill in the blank, but it needs to be something where we're not saying, every year you get a $3,000 raise, right? It's on average, we would expect your raise to be about this much. So that's pretty much it for interpreting slope. Obviously here, we're just going to fill in the y and the x in terms of the context of the question, right? Every question will be different, but in general, that's how we're going to interpret it. Now, if I take that same example, right, if I rewrite this, right, 7 plus 3x, where x was our number of years worked, and y was your salary in thousands of dollars, right? Now, let's say they asked you now to interpret the Y-intercept, right? So if I'm going to interpret the Y-intercept, or in reality, what you'll probably just see is they'll just say interpret the intercept, right? Here's what we're going to say. The general rule here is when x equals 0, the predicted y is blank, right? And again, very specifically here for y and for x, we're going to fill in the context of the question. And so you don't need to literally say like when years worked equals 0, right? In the context of this question, well, 0 years worked at this company would just be like your starting salary, right? So here, my solution would be, right, with 0 years of experience, if I really want to go that way, right? Or, right, or we can say something along the lines of when starting at this company, right, there is a predicted salary, and again, this word predicted, very important, of $7,000, right? So you can also say, the company has a predicted starting salary, right? So maybe I'll just write this out too, right? Here's one example, another one, right? The company has a predicted starting salary of $7,000. Boom, right? Still puts it in context. X equals 0. I kind of like the answer in green a little bit better just because it will like check all of the boxes. And here with my answer in blue, I would still be like starting salary parentheses X equals 0 years. Because again, oftentimes in the scoring guidelines, they say specifically that you have to make reference to whatever the X variable stands for being equal to 0. But still, this general format here of when X equals 0, the predicted, again, important, right? The approximate, we would expect all that same type language, is very, very important. Without that, you probably lose some credit. So for our interpreting the slope here or interpreting the Y-intercept, I hope that makes sense. If you have any questions about it, please write them down and we can talk about them when I see you guys tomorrow. Now, the last thing I want to cover in this video today is something called a high leverage point. And that is what we were talking about with the point that was really far away on both X and Y, right? So a high leverage point is a point that's significantly far. I'm putting this in quotation marks because obviously we don't have a concrete definition of far from the rest of the data. Now, there's a big reason why this is called a high leverage point. And to demonstrate that, I have this little Desmos thing here that we can take a look at. So you can see here, right, in this table that I have, I've got, X values 1 through 5, some random Y values. And then this point up here at 25, 165, right? And right now, it's no big deal, right? So if we look at the regression equation, like if I look in this box down here, it's 6.8x minus 5. If I get rid of this point here, well, now it's 6.9x minus 5.5. So very clearly that point didn't change my regression that much. Well, now let's say instead of 165, I just use this slider that I've put here called A. Now notice one thing immediately, right? My slope is now less than 4, and my y-intercept is now positive. But one thing you'll notice, because this point is so far away, I can literally pull this regression equation and make it completely and totally negative just by changing that point. Wherever, if I zoom out here so we can see this whole thing play out, right? Wherever that point goes, the line goes. Let's slow it down just a little bit for us, right? Wherever that point goes, this line follows, no matter what. And it's incredible, right? When you look at this and you think to yourself, like, why would that be? Because if I did something similar here, so bear with me for 1 second while I have to just create another variable for us, or another slider, right? Like if I took 3, and instead of having 14, I put C there, right? You'll notice that even if I change this range to be like negative 100 to 100, C will not change this picture nearly as much, right? Even going all the way up to 100, all the way down to negative 100, yeah, my equation definitely changes a little bit. But even if you look at the values of the slope that are changing in here, it's going from 8.5 or, almost 9 to 7, right? It's going from positive 7 to positive 9. Whereas if I put this back to where I wanted it to be, which is just about 12, I believe it was, with 25, I'm changing the slope from a positive 8 all the way to a negative 8, probably at the very other end, or maybe even more, right? So why does that happen is the biggest question. That this point here can pull the line wherever I want, but this guy really doesn't move the needle all that much, right? Well, it comes down to, let me put this back to where we wanted it to be, right? It comes down to residuals, right? If you remember, our line was roughly 7x minus 5. This was roughly the regression equation prior to me moving this thing, right? Now, if I want to think about residuals, if I zoom way in here and I look at these data points, let me make this what it was before, which was 12, right? No, not what I wanted. There we go, right? The residuals on all of these purple points on the red line are not bad at all. However, if I look at the residual for this point over here, on this red line, that residual is absolutely gigantic, right? So the idea of wanting to minimize residuals, if I get rid of this, these residuals around these points, regardless of where this line goes, don't really change that much, right? They don't get super huge or super tiny, right? Obviously they change, but not nearly as much as you can see our point fly by here, not nearly as much as the residual that would possibly change for this point that's really far away when x is 25. So by the nature of wanting to minimize the sum of the squares of all of the residuals, this point over here at 25 pulls absolutely everything towards it because it stands the most to have a residual that's gigantic. So wherever this point goes, this line's going to follow because all of these points that are grouped together, their residuals aren't going to change nearly as much as that one point that's really far away. So for that reason, we call it a high leverage point because it can leverage the regression equation, and more importantly, it's going to pull the regression towards it. No matter where it is, it's always going to pull the regression up or down, wherever it may go. So I hope that makes sense for all of you. I'm going to leave you just a short free response question today so we can look at the interpreting of the Y-intercept and some other things, and see just what AP might ask you. So I hope that makes sense, and I'll see you guys tomorrow. Bye, guys.